Hello, good day. My name is Jude Chukodi, your facilitator. You are welcome to the 12th of our machine learning class. I will have a lot to do today. This video may cover up to 2 hours. It's divided into 2 parts. First of all, I want to teach you how to bring in data into the Python environment, either through the notebook or through the Jupyter notebook or through your file data, file profile where your file are kept. After which we go ahead to touch on the Pandas transition from Pandas to machine learning that I have today. So follow me closely because it will help you in your work. So when you want to bring in data into the Python environment, because looking at this work that we're doing now, there's always a place where we'll definitely bring in data. Let me just go down a bit so that I can see at this particular point, PD root CSV house, we are bringing in data. So when you want to bring in data, let's run our work up to this place. You come to cell, let's say run all above. So after it has run, it will now get to the next one, which is this. Now you can bring in data by using this format. Anytime you see df in the front equal to, you are defining what you want to do. Whatever you put in the front before the equal to, Pandas take it as what you want to use, the type of data or the name you want to use, and it expects you to use that name throughout your work. If not, it will throw up error. So for us to use a data that has this name, it means I must have brought it into the Python environment. So that means when you come to this home page, it must has been saved there. Must have been saved there. Now let me open this environment to show you how this can be saved. Now you want to save this, you can first of all come to the home page. When you come to the home page, you go to the top, you see where we have upload. So you go to the upload and click upload. It will now take you to your file in your Python file. For instance, I have this COVID. Okay, let me say I want to save this. This is a CSV file. Of course, you can see the design. You will come to, if it's coffee you want to bring in, you can now click on this coffee here. You come down, you see file name coffee, you open it. Open means you have now brought it into this environment. You see we have coffee.csv and it has space for upload. Once you click on the upload, it has uploaded. So when you come to your file, there's a space for file, down. You see we now have coffee CSV. To tell you there's a new file, you see it was just uploaded seconds ago and the weight is also indicated, for instance. So if that is true, you go back to this page that we are working with and you want to bring in that coffee file. Remember, we're not using it just for our class. So you will now, because it's a new file, you may decide to go to your kernel and restart again and clear output, or just restart. It's all about restarting your kernel again so that you can have it in memory, as if it doesn't have it in memory. So if you have done that, it may be good for you to come again and run, no, not this one, maybe for you to come back again and rerun your file. Rerun your file again. So this is for this data set. We can decide to now bring that coffee that we just put in now. Comment this out. Just copy it and change some things there. And come down, place it. Then we'll now change the name of the data now. What do we want? Coffee. Be sure of the spelling of what you want to put. So to be sure, you look at it again. Capital C, then E, okay. So you come back here and you now put that the way it is. Capital C, F. So this is what you want to see now. See, we have commented the first one. So when you run it, and you come down, you want to see the data head. You see now what is showing here now is coffee data. You can also do that here. You can even come here, come down and just write df dot head, and when you run it, when it runs, it will give you coffee dot head. Or you want to see something else that is not coffee, you can go again to this our page here and check out for it. For instance, you want to put COVID data CSV. The way it is written is how you are going to put it. You come here again and you just remove the coffee. Small c COVID data and run. Now this is COVID data. So this is how you can bring it if you have saved this work in the Jupyter notebook handle. It will do like this. Now alternatively, it's possible you don't have this saved in that place, or you want to bring it from the file directly. So how do you do it? It's also easy. So what you do, instead of writing this COVID data here the way it is, you will go to our file, go to our file page, open our file page, go to where you saved your data that you have downloaded from anywhere into your file, to your computer. When you go to the place, like in my own, I'm going to where, because my work are all organized. I have a database where I keep my data, and the database I have where CSV file, other files. So in the CSV file, I look for my COVID data. This is COVID data. So how do you work with this COVID data? Click on it, then you right click. It will show you cut and the rest, shear and the rest. You leave it, you go to properties. When you go to properties, you click on the properties. The properties will come up. You see that everything is there. This just to see this file came from another computer and might be blocked to there. So if that is great, you just click on the block so that you're assuming it is blocked, it will not stop you from work. Then you apply. So after you have done that, you can now click OK and come back again to it. Click it again. Go back to the properties. You see the block is no more showing, but it's showing that it's a CSV file. Then this is location of the file. You copy this location. Copy this file location. Just observe what I'm doing carefully. Control C. Then come back to your work. When you come to your work, you can remove this, or you can also remove it, or you comment it. Doesn't matter. I just want to show you how we do it. You now Control V. We have not finished. Remaining one. Put any stroke. Watch the stroke I put. It's different from the stroke that was there before. Now you go again to that properties again. I have not finished. Now the name of the file. This is the location. This is the name of the file. Copy it again. And you go again. And you Control V it. Everything will end with .csv because you are reading a CSV file. But it is not okay here. You see that the stroke is going rightward and the stroke I put is going leftward. Now ensure that you have a leftward stroke for all the places that have stroke. If not, your file will not open. The way it is there, that is how you look it. If there's a space, observe that space. If not, it will never open. Now you have now brought in from the file location. You can now click on run, and it has opened for you from the file location. Now let me just do something. Let me just maybe remove one stroke, for instance. And when you see that it will encounter error. It has encountered error because it doesn't understand this location. So until you put it back again and you run, then the file will run. So this is how you can bring a file from either your file position or from the one you have saved. So those ones that we have saved in our Python environment Jupyter notebook doesn't have this definition of location, this long definition. So assuming I still want to use what I used before, which has already been saved in a Jupyter notebook, I will just clean up this section that located it from a file and don't leave it like this and run. It will still open, but it's not the same location. It's not the one that has been saved inside the Jupyter notebook. So this is very, very important. And once you have changed a file location, even if you have it stored before, it will not open again because that location has been altered. So always be sure that your file location is correct. If not, you have problem loading, and the name of the file is correct. Sometimes you have Excel file that is writing.csv, it will never open. If you're opening an Excel file, it will end with .xlxx. So if you're opening a CSV file and you put .slss, it will not open. So this is just a little the instruction I want to give, because you need it when you start to bring in file into your Jupyter notebook. I hope it makes sense. So we're going to remove this and we'll start our proper class now. Our class proper now. remove the comment again. Comment it. Okay. So our class today is the 12th class. We are looking at some important aspects that will help in our work. Want to begin to look into the workings of machine learning. We cannot look at it if we have not considered Pandas, which is a very important aspect of machine learning. Pandas has a lot of working tools that helps us in our analysis. So what we are going to consider today are plenty. Introduction to Pandas, which you have already known. You have to look term and five, but so all these items are going to be considered because they are very going to be handy when we start our work. So we'll go straight to our introduction and look at Pandas library. And we know that Pandas library are very useful for data processing and data analysis. Of course, we're going to bring in the libraries. So we also look at other library that is also closely knitted to Pandas, which is NumPy, which is always good for calculation and manipulation. So Pandas data frame is always a two-dimensional tabular data structure which has rows and axes. Once it's only one, we call it series. It can also be either horizontal or vertical. But once it has a column and it has a row, we call it a data frame. And it is always a kind of structure that is used in our workings. So we import Pandas with an alias name PD, and we import NumPy with an alias name NP. Now, it is not me that name Pandas PD or NumPy NP. It is the convention, and that is how it is used. So once you are doing a work, always follow that convention, because if you name your own Pandas GG may stand for something else somewhere, which may conflict with your work, and if your work is going outside with the community, they will get confused. So it's good you maintain what the community is doing. So run it. So I use data I define as my data. I'm using NumPy random. I generate a random number. We starting with 0, and the number will not exceed. The highest point you can go is 100, and this is the random digit we are using to make a manipulation 4 and 3. So when we run it, it will go into memory. I want to see it. You see that those values has been given. So I would like to set a phrase by going to my kernel and resetting and clearing our output, so that we'll be opening it as we are going. Okay, so we have run some already up, so I will come again and now go to my cell and run all of them that are above, so that will be on the same page. Okay, so this random digit has given us these values randomly generated, and they are in array, and the array means that we have columns and rows, and they are what into 3 rows, 3 columns for us, 3 columns. So we want to create another one called my index. So my index also to have the name of countries. So let me correct this is India. Let me use capital letter I. Japan, Australia, New Zealand, capital letter N. Okay. So we run it. We commit to memory. Also, so the column will bear the name of month. So we'll run it too. So now we want to create the data frame. Normally, I have my data that is already there in the data frame, but I have not put it in the data frame proper. And we have index and column. So I want to bring everything together now. So I use the data frame that I'll be using pd dfpd data frame. That means I want to put it in data frame. I want to put my data, which is this, and I want to put my index, which is this, and I also want to bring in the column, which is this. So when we run it will give me the data frame I desire, having the month on the column and having the names of country on the index. So that is simple way you can see Pandas working. I want to now go proper. We want to bring in a data frame. So I bring in data frame from our Jupyter environment. And mind you, Jupyter is all about Julia, which is Jupyter notebook, and one more record, one more analysis tool, which makes up the Jupyter notebook. That was the first target before it expanded. So now I want to see this data frame house rent data set has already been entered into the memory, but we want to see the head and the top, which is normal convention. When you are opening up a Jupyter notebook, sometimes the rows may run into millions. You don't need to open everything. It will consume your memory space, and sometimes if you don't know the total number before you start, it may even crash your system. So it's better you just look at the top row and sometimes the bottom row to give you a view or an understanding of how the data looks like. So when you run it, you see that the data head has come up for our data house rent data set. Okay, I also want to do one more thing for this house rent data set. Want to understand it. So when you go to the file, for instance, we'll have it somewhere here. We'll open the glossary, so it will also give us a view of what is there. You see that we have BHK is number of bedrooms, hall, kitchen. The rent is rent of house, apartment, and flat. The size of houses or apartment or flat in square feet. The floor is, so it is defined so that anybody that is working will have a kind of understanding of what is working with. So it is there, and that works. We'll go back and continue. In case you have any confusion, we can always come back and understand what that means. So we have seen the top 5. Another thing again we always do before we even bring this into this environment is to go to our CSV and look at our data. This data that we are brought in, how does it look like? What and what are we looking at for when we are using it before we even go to bring it up into the Jupyter notebook. So for you to actually have those proper view, you do something. You come to this under the home tab, you come to the filter aspect sorting. You just go to filter. When you click it, it will give you like a drop down arrow for all your columns. So with it, you can still look at it properly. You can look to see that there's no missing value, This is a data that has 2022. That is only year it has. I have only 4 months: April, May, June, July. So it has given you a view. Then this BHK, it is from 1 to 6. The rent, you see, the least rent is 1,002, and the highest rent is 10.5 million, and there is no blank space. The floor. So you look at it like this. You look at the city. How many cities do we have? We have 6 cities in all, and there's no null. So after that, you can go back to your work, but it's always good you have it by the side. It gives you a clue of what you want to do, so that you don't work blindly. Remember, we're data scientists. We look at things more in details than other people. We see what others are not seeing. So after we have looked at this, you can also look at the tail data, the tail part of the data, which is the ending part of the data. We always look on, and when you put this bracket, automatically by default the system will look at the 5 rows. Excuse me. So you can see these are the 5 rows. So we'll continue our exploration. So to get the name of all the columns and how to rename the name of the column. So you want to get the name of the column, all you need to do is to use the command df.columns with s, and when you run it, it will give you just the column. So the index that is going there is the top, so it gives you the column name, and the data type is object. Then you can also look at so to get index, just to get the index, you put df.index. Index is that first left hand column. It can have number or whatever you want to put is there. So for this, we have our index, and the index is range of the index. It starts from 0. Normally for pandas, we don't start from 1, we start from 0 up to the last number. So it starts from 0 and it stops at 4,746, and the step is 1, which is it has one number at a time. This is what it has done us here. So assuming you want to rename your data frame, so this is the command you use, df.rename, and you're renaming column. Is the columns you are renaming now, so indicate it. And the column will have posted on. We want to change it to date. You also have point of contact, for instance, and you want to just say contact preference for the sake of teaching us how to change. So if you have this, you can change one, or you can change more than one. If it's more than one, you use comma after you have done what you want to do. So by the time you now run it, it has changed. Now you now want to see what it looks like now. Now you run the new one. So you can see that the posted on has now changed to date. Also change it, and the point of contact become contact preference. We also want to see our information with respect to our work. So when you gf.info and you open up this with a open bracket, you can give it the information that you want to see with respect to this data. So it's pandas core frame, data frame. You have range index as you are seeing. It starts from 0 and end in 4745, giving us this total, and the total column is 12 columns, and the columns are indicated here. They are, whether they are null, it will look, when you look at it, it will show that it will tell you whether there are missing values or not. Then the data type is also indicated here, whether they are object or integer. Now the data types are 4. 4 are integer and 8 are object, and the memory space that is consumed is there. So every information you need has been given to you. Also want to see describe. So in describe mostly, unless you put describe.all, it will only give you the integers. The reason is that integers has meaningful analysis which you can understand. Now when you want to look at all, discover that most of them will be showing none, which is non-value or null value, which does not make sense. So this is how you can see it. So the BHK, rent, size, and bedroom are all integer. Remember, we saw 4 integers. So it's describing it, showing you the mean, the standard deviation, the minimum value, the maximum value, and the interquartile range, 25%, 50, and 75. So this is how you can see it. You can even run this value, but we'll do run later as well, progressing. You can also transpose this. Transpose means taking the things that are in the column to the row and the things on the rows to the column. So how do we do it? We come here, we use dl.describe.transpose. So when you do, you see that our values has come up and the integers has come to the other side. You can also achieve the same thing by using, instead of writing .transpose, just write .t, and it will still run and give you the same thing. So you also, there's a way to extract a single column or multiple columns in a data set. So if you have something like rent is part of the column. We want to just look at what is on the head of the rent. You can come and run the df just rent. So when you run it, and we are looking for just the first three columns, you start from index 0 to index 2. So you only give us the values of rent for those 3 indexes. Now, but when you want it to be in data frame, you now double the block bracket. When you double it and you run, it will give you a data frame kind of arrangement. So you can also do it for more than one column, so it doesn't end in, but it will be in data frame. So you have this comma that separates it. Because it's a text, you bring in your apostrophe, whether it's a single or double inverted comma. So when you run it, it will give you a data frame arrangement. You can also add column to your work. So adding column, we define the column, and this column we want to add is called fresh view. It can be any name of your choice. And fresh view is data and its rent. We want to divide rent by size and multiply by 100. And also want to reduce whatever we have, the decimal places, to 2 or to 1 or to 0 as the case may be. So it is called rounding. So when you are rounding, you cover, after you have defined what you want to do, you bring in the round and encapsulate it with what you want to do and put a comma and write the number of decimal place you want to see. So that is what we have done here. So when you run it, it has run to memory. You can now see it, what you have run it. You can run it to 1, 2 if you wish. So if it is 1 decimal place that you want, and you run it, see to be on 1 decimal place. So running is at this discretion. So we want to see the head of this new work we have done. So put that head, and now I want to see all data frame, everything plus the new one, the fresh view that we just added. So when you run the data frame dot head, it will appear, but it will always appear at the extreme right, just like what we saw in Power BI. When we are running Power BI, it will appear in the extreme right. So this is the new column that we have added. So it is quite easy. You can also drop column. So for instance, this column we just created now, we can also drop it. So how do you drop it? You use the command df.drop. So dot drop is the name. It can be anything. It can be data.drop. It can be jude.drop. It can be tunji.drop. It can be victor.drop. It doesn't matter. But df, the dot drop, is what gives the command. So what are you dropping? You put the name of what you want to drop. Then you also indicate the axis. Remember, the axis, when you want to drop, column axis are referred to as 1 and row axis are referred to as 0. So we are working on the axis, so axis is equal to 1. In place is true, meaning that whatever we have done is committed to memory. We are not going to see it anywhere else again if we have dropped it here. Assuming we did not put in place true, after we drop it here, in subsequent work we'll come again, we'll come for the head, we'll see it appear because we did not remove it from memory. So we'll use in place true to remove it from memory so that it doesn't disturb our work. So if we have done that and run it, you can get a new data head. For this, we are trying to explain that you can also remove more than one column at a time. So you can remove date and fresh view. Axis 1 in place true. Always note the spelling so that we don't misplace. In place, not in place. In place true, capital. Excuse me. In place true. So we want to see the data frame, the data head. Excuse me. So to see the data heads of this one we have done, remember this one we're just commenting it. We're telling you you can do it. So you can open it and do it yourself to see how it looks like. So to get the data head, you come again to check for this fresh view, which was at the extreme. You see that it has gone. It has also been removed from the memory too. So how to set any column as index? You can also set columns as index. You know, index by default is set with number and it starts from 0. But you want to change it because what you are doing does not make sense to start with those numbers. Or if you want to put it in normal calculation or mathematics naming that will start from 1, but you go to any number, you can do it. You can start your index with alphabet or with name. It is you that does it. So for here, we want to see something. We want to set our index now with BHK. Let's see where BHK is located. BHK comes after date. I want to use it now as our index. So observe the position and how it looks like. So we use df, which is a data frame, is equal to df.set index. An index you're setting is BHK. So dot head. Want to see how it looks like. The first 5 numbers. So now say show us this new data frame. Because the BH has been set as index, it comes a little step down to the index position. It has left the position it used to be. Now other ones are on the top surface and BK is below by 1 step. So now it is now the index position or the index of this one. And assuming we want to reset back this index back to its original position, original status, we use the command df.resetIndex. It will bring it back to where it was before, but the positioning may not be as it was. See, big K has come back. It is now before date. Date used to be before this big HK, but it doesn't matter. But things that they are now on the same level. It is no more serving as index, and index has come back. You can see our 0, 1, 2 has come back. So what we are doing is to teach you how you can do all this, so that when you have a project and work at hand, it will not be a challenge. So to select any specific row with index position, you want to see a particular row, you want to observe it to see the things you want to take note of. You can do that with this definition of this command, df.iloc. That means index location is 2. So we want to see what is on index location 2. So when we run it and you look at index location 1, 0, 1, 2, this is index location 2. Information that are here is what we are seeing here. Let's take it up a bit so we can look at it together. You see, 16/5/2022 is the date. The BHK is 2. The bathroom is 1. Contact owner, semi-furnished. So this is how you can do it. You can even want to see the index location 0, for instance. So when you run it, whatever is index location 0 is what we are seeing now. This index location 0, super area, bundle, calculator, furnished, unfurnished, bachelor, family batch. So this is how you get the location, the index location for the row. Just pick one location, and this 0 is row 0 or row 1, row 2, or any number of row as the case may be. So for selecting some on subsections of the data frame, you want to pick not all the sections. There's some things you want to do. You want to cut those sections that you need and bring it out. We use this df iloc. Then you now define the row position or index row position you want to see. For this, we want to see index row position 1 and 5. That means we don't want to see index position 0. So it starts from 1, and let's run it and see what it will give us. See, it has got index position 0. It starts from 1 and it ends in index position 5. So 1, 2, 0 is the first one. This 2, 3, 4, 5. So don't get it confused. So it starts from 1 and end at 4. That means started from 1 by number, and this 5 is counting from 0 to 5. This is where it cut. So this is what it has cut. So we can able to study this. We can copy this. We can grab this. We can do a lot of things with this. We can even chat it and explain whatever we want to do as explanation. So it's what we can do with it. So here too, we can with this we can see set our index position again to BHK. If we have cut it off, and see how it looks like. See, we can use it again just for this one that we have cut, and it will still give us what to see, what we want to see. So we can also run, just want to just see index position 2, as the case may be. We'll have a lot of them, so it gives us some. So we can also look at how to drop rows. So to drop the row, we are dropping what? 2. We are dropping row 2, for instance, and the axis is what? Is an roll argument. So it give you axis is equal to 0. But you see, this one we didn't put in place true, because we'll still work with it. You just want to drop it for the sake of teaching. So when you run it, it has dropped the index too. That's why we're not seeing anything here. Then when you want to see data frame 20 data frame, 1 2 3 4 5, so it just gave us 5. It does that sometimes depending on what you are doing. Depending on what you are doing, it can also give you detail. Just pick 5. So we have conditional formatting. The reason for conditional formatting is that most of our data, the rows are much. Like what we're working now is 4,000 data. There are some that are 3,000 data, some are 50,000, some are even in millions. So if you have such data, you want to filter based on position, it may not make any sense because we'll be trying to feature this position. So we can mostly filter based on criteria, on certain qualities or certain conditions that we want to see. So when we do it along that position, it will make a lot of sense. So we need to organize our data maybe by single condition, multiple condition, or any other condition that we wish to use. So we now want to bring in our data once again, so that we have done some work with it. Let us bring a new data again, the same data, and work with it. So when you look at it, you see that this data is still, there's nothing missing from it, the way it was from original posted on. Point of contact is there the way it was before we did some work with it in the other side. So now I want to look at rent. And when you look at rent again, let's go back to our CSV file and look at rent again. See that the minimum of rent is 1,002, and it goes down to 3.5 million. Okay, so we want to view only the rent that are greater than 40,000 value, whether it is dollar or any other currency. I want to see it here. So what do? We run this command, new data frame, block bracket, data frame rent greater than 40,000, we close. So what we are seeing here are just the data frame, the data that are above 40,000. So you see from 104 down, because it was arranged as if it was arranged in ascending order. So it shows dots, and when you see this dot, it means that there's information that are embedded that they will not see. So they just cut it and show you the last ones so that you can be able to have a view. So total is 919 rows is what obeys this instruction. So 919 rows of our data have values above 40,000 currency. So that is what we're able to use that to do. We can also look at another column, which is area type. We want to see the built area. You know, area type has 3: one carpet area and super area. So we want to count the number of the values in the built area. So we'll just run it. You see it has 2, and it is 2 located across all the other columns. So for the carpet area, we also have some values, and for the last one, which is the super area, also have assigned values. So we can be able to use it to differentiate, demarcate, and view or observe values according to the specifics we want to see. So we can also run our work to get can use ampersand to join, to use, that is and value can be used, ampersand can be used to bring 2 values, 2 different columns with different qualities together or we can use or when we use stroke. So when we do that, for instance, we are trying to do what we call in set theory union. In union, you are looking at what is common to the two set of value you are considering. So for here, the new data want to see the rent that are above 30,000, and at the same time the area that is super area. So the rent that's above 30,000 that are in super area only, not any other place. That's what we want to see here. So if we have that, we can run and get that into our space. So we're only seeing the first 5 rows here. So that is why it is showing us first 5 rows. Remember, we can also do something here. Let's copy this and see what we can do with it. Let's see, pull up a new row, put it here, and then see if we run it like this. What it will do is to show us the numbers of rows that was able to be obtained using this idea. So it's 260 rows. Remember, it's intersection. It is a intersection, so it always have lower values. So other one we only saw the head, not the first 5 rows, but now we want to see the total number or the value that was able to be gotten based on that criteria. So we can also look at the tail, run and get the tail, and the tail is almost the same thing here. About the same thing here. So you can also use another kind of way, which we call is in function. We have a lot of function. It is your work to discover them. As you discover them, you put them to practice, and it becomes internalized, and you become part of it, and it helps you in your data analysis. So want to try this is in function. So we'll just give a name option is equal to, we define this super area and built area, or it's a super area. The other one is carpet area. Carpet area first. Let's see how it looks like. So when we run the function, so we'll now bring it to our area definition, which is area type. We want to only see what is in these two. We have refined this now as option. So we'll run it. So what is giving us when we come down is 4,744 rows. Remember, we have 4,746 rows, and the built area is only but 2 values. So if we go up again and say, okay, let's just put in the built area now. Let's remove this carpet area and put in the built area. The built area, and run it to memory first. Then when we run it, and see how it looks now. You see, it is 2,448 because we have removed that too. We have removed the one that has much and only put our built area, and it has affected our result too. So we can also use apply function. We can use apply function for work. So what if I want to grab the last 4-digit number of the rent value, for instance? So use the find last 4 number, return strings, and always ensure that you follow the identification rule. If not, you will not have a value. Okay, let me just digress something so that you see what we mean. Now you see everything is look like the code is okay. There's no throwing of error. I will come here and run it. It will tell me that identification error has occurred. So if such occur, I can do what? I can come here, take it up, and bring it back. It will pick the right identification for it. Once I've done that and I run it, it will run to memory. So I want to see the last 4 of this digit, and I run it. And the instruction is that you are cutting from the left to right. That is why we have -4. So you start from -1. Remember our list rule. When you want to cut from here, it is 1, 2, 3, 4, 5. That is how the index, the digit counting goes. And if you want to come from here, start from -1, -2, -3, -4, as the case may be. So we want to start from -4. So we'll start from -1, we'll go to -2, -3, and -4. Anything outside -4 is what we'll cut off. That's what we have told the algorithm. So when you run it, see that it will give 0, 0. Assuming you put just 4, it means it will count 1, 2, 3, 4. Then it will cut off this one and leave this one. So assuming this is the instruction and you run it, see it will give you 0. So have that in mind as you work. It's there for your manipulation. So after we have done this, to understand what we want to do, we'll now come to our data frame and apply this last 4, which is the what we want to do now, to our rent, and apply it and see how it looks like. Now we have our new data head. Now normally you always see any work that has been added at the last right hand side. So you see, this is how it will cut off our work until the last value has been gotten. Also do some yelping here. So for that, we'll define it. So yelp is the price, and say if price is less than 1,000, return the sign, $sign, single $sign. S if the price is equal to 1,000 but less than 30,000, bring double. But if it is greater, if it is not obeying these two conditions, then return it as 3. You can always change the value as you want, but once you have said this, you have defined this, that is what the system will do. So now do new df here. We now want it to be applied on the rent, and we run it. So when we run it, we can come again to look at it. You see our year has been added. So these ones are above 1,000 and they're below 30,000. So we can see that double $sign has been addressed. You can put whatever you want to put and it will appear the way you have intended it. You can also apply function with multiple columns, like we define quality, and quality, the column is rent and size. Then you define that if rent size is greater than 0.5, return generous, else return other, and you run it. And define quality now, giving the quality say is generous. So this is part of it. We can also do sorting method in Pandas. So bring back our data again afresh in order to do that. The data is intact. So for sorting, we can sort the value of our size. When we're sorting value, we have some argument. The argument is whether it is going to be arranged in ascending order, because by default it is working in a if you are sorting and you do not indicate, it will pick the size. It will normally pick from ascending, from the lowest to the highest, if you don't describe or instruct what to do. That's why we say for here ascending, you say it's false. That means you want to see the highest value and it continues to come down. And if you are not sure of what is going to happen, Let's work this one first and see. But if you're not sure, you can always write true or false, and you see the direction of where it's going to. So it is working, so it is sorting based on size. So the size value starts from the highest and continue to descend, because we say ascending is false. Okay, now if we have said ascending is true, let's see how it look. I run it, and this is the size. You see, it started from the least, continue to go down with bigger value. So go back again and put it false. So we want to sort by false. Okay. You can also sort by size and rent at the same time. So when you are sorting by size and rent, and you did not indicate, you see that the first one that is indicated is the one that will take precedent. It's after the condition of the first one has been taken before second one. And because the size, we did not define whether it's ascending, true or false, it will take the default, which is from lowest to the highest. See that the size started from the least size and it continued to increase. The rent is not doing that, but it's after we are finished with size that rent can tell. If you want to see, you can also shift. You can shift the rent first, and we bring in the size and see again. I'll run it. See now, the rent starts from the lowest and continue to increase irrespective of size. But the thing is that after you have finished your condition for the rent, size will follow. That is what it means. Okay. So there is room also to us to get our minimum, maximum value, and also their index position using our Pandas algorithm. So what is the maximum value of rent, and what is its index position? So to get the maximum value, you only put df rent.max as the command. So when you run it, you see our maximum value is 3.5 million. And where is the position of this maximum value? You use this instruction IDX, index maximum. That is the argument. So when you tell that its position is on index number 1837, so our maximum amount is this and the index position is this. That is what we have been able to do. We can also do for minimum for the same rent position. So the minimum value is 1, to which you have seen severally today, and then the position is on 4076. 4076. So that is the position. You can also look at the index location of a particular row. You want to see what is index position of row 67. So when you run it, whatever is in row 67 is what you are seeing here, like what we did in row 1 and row 2 initially on the top. So you can be able to have your view and do whatever you want to do with respect to that given row. You can also look at correlation, and looking at correlation, you use df.core with the bracket. It will give you this. So and it's always giving you on the integer of your value, so you can see the relationship between values. So here you can see what is correlating with what, and know when we have independent variables explaining each other, it will look to autocorrelation, and autocorrelation is not good for work. But we use this formula, this instruction, to see what is correlating with what. You can see that the size of the house are correlating with BHK to the point of 0.72% correlation, which is very high. And bathroom and BHK is even higher, almost 79%. So this is what gives us that information. We can also look at value count, unique and number unique, replace and map function giving our data. So for us to get value count, and mostly when you are looking for some of these value counts, it's always good to use integer. It admits both integer and objects, but integer looks sweeter, but it doesn't mean that you cannot use objects. So for the area type, we want to count the value, so it will give you the different type and their count. See, it says super area, this is the number, carpet area, this is the number, built area, this is the number. So the name of what you have done is this data type is integer. It has given you everything because you are counting. You can also look at the unique. I'm showing you the column. Almost the same thing we do when we're looking at the top column. So for the unique, you see that we have super area, carpet area, and built area, just the object, not the value. Now we can also look at another one like city. You can tell out the city. So when you see in the column city and there are other values there which you don't know, you can use this to get it. You can also count the unique values. That is n is number unique. So you can count the unique values using this. Say there are 6 values. So calculator 1, 2, 3, 4, 5, and 6. So 6 values. So how to use replace method? We want to replace some of these values, assuming the lengths are very long or the name are not in the code or the context you want them to look like. You can always change it. So we're showing you how you can do that. For instance, using the area tag, you can use dot replace, then bring in your work, state the items you want to change with what you want to change them to, and then close, then you run. When you have done that, you have now replaced those areas. You can also use mapping to do the same thing. For map, you say my map, it says super area, but you are using the bracket. Super area, you put your double indentation. What you want to change it, you put it. You go to the next one, indicate it. That is how, after you have done that, you now define my type area dot map. You now map it using map my map of what you have done here, and it will automatically replace it for you and will give you the same value. So in most of our work, we always have duplicate values, those values that are duplicative, which does not make analysis good. So we can always identify them using some of the work we have done. So here duplicate, assuming there are duplicates in this work, you will use duplicated or sum to look at it. From here you see there's none, but assuming there are, it will tell you the number. Then you can also drop it. So you can drop them. But because there's none, it is still just like working on a clean value. So you can use between function to also pick work within a given range. So for rent, want to look at the rent that is within the range of 1,000 and 30,000 inclusive. We now use this formula between. When we use the formula between, we run it. Say df.df rent dot between, then the value inclusive, telling us that it's going to be deprecated, no problem. But we can see the value, and we can also see the number of rows that have that instruction obeyed. 3,501 row. And also see the largest and the smallest number. Largest number, we want to see what is the largest number and what is the smallest number in our work or in a given column. Use df.n largest and run. Want to see 5 of it. So we pick 5. We want to see any number, you indicate it here before the value you want to work with. So it will always show you the index position. Remember this 1837 we've seen before, followed by 120, and the lowest of the 5 is 70,000, and the information I have to do with it. I also see the lowest 2, then on the code for the lowest. See the lowest is 1, 2, and these are how they are all described. So also we can pick random numbers and then sample. Sometimes in our work, remember we say sampling theory ensure that the population is represented with the sample when you don't need to work with population size but sample size. As a true representation of the population, you can also use random sampling. So to use random sampling, you df the sample, then you want 5%, then you run. For here, we just want to see 5 values, but it are taking a sample, and that sample is 5% of the sample actually, but we're showing us 5. Then we can also use another DS sample fraction to show you the 5% that you want to see. So it will give you 5%, and the values are there. 237 row. To tell you that is random sampling, observe the numbers here. Let's run it again and see if this number will remain or if it will change. See, it has changed. Run it again. Run it again. So it's random sample. It is picking it by randomly, and it's a true representation of the population. So how do we handle missing value? You know, missing value is one of another big challenge in data science and statistical analysis, because they represent samples that were not well repeated, and they may pose a lot of problem to us. So real world data will often be missing values for different reasons, and sometimes you see them as none, and those one does not help in analysis. So we have 3 options when it comes to missing data. One of the options is either to keep it, the next is to remove or replace, and all of them has their good and their bad side. So when you keep your missing data, the good side does not manipulate or change the true data, but that method may not be supported by analytical work, so you may not get any work. You cannot use it to do an analysis. Now when you drop or you remove missing data, It is easy. It can be done based on rules, but you will lose some vital information which may be important for your workings. Now, when you are filling data too, discover that you save those information that you could have lost, but you somehow may possibly give us a wrong conclusion. That is why we have a lot of rules. One of them is that you don't remove value if the total number is above 5%. If the value you are removing is below 5% of the total work, you can remove it, and you will be sure that what you have is still close to the real value, the real conclusion you will get. If that is, but it's the last option you should explore. So the first option is to see what you can do by imputation. An imputation, you can use arithmetic mode, arithmetic mean, or the mode, the mean, or the median. When you are working with integer, you use the mean, which will give you the average value. And when you're having work that has mode, you use the mode, the number with the highest value, and you can be able to use them to do your replacement, and your work will still be good enough. So we want to run in a new data, which is COVID data CSV. So let's have a look at our COVID data. Remember what I said when you have this, open it up, look at it again, have a feel of what you want to do, let it make sense to you. Okay. The next thing you do, you come to sorting, which you can see in your home tab, or when you go to your data tab, you can see it at the middle, filter. Any of them can be able to give you your sorting criteria. So when you have this, you now come and put your filtering, click on the filtering. So you have filtering on each of the column. So you now look at them again once again to see if you have missing value or the kind of data you have. See the kind of data you have. There is a date function, and the date function already 2020 and 2019. Okay, you can still open it up. We don't need to open it up now. You see new cases. Are there new cases? There's a report. See if there's a missing value. This value is complete. You see new date. New date is also complete. See population. Look at it. There's blank, then there's missing value in the population. There's age, 65% age, older population, also have blank, and it's a float value. Look at the GDP per capita. See, this also a float. Let's see if it also have a null value. Hospital bed. It also have a null value. So this is exactly the data we want to use for our next analysis, because we want to handle what? Missing data. So we want to read it in. Remember this formula, the way it is, I've already saved it in our Jupyter notebook, so I can call it using this as you follow the rule I set in order to get from your file. So we want to see the head. So this is the data location, this is the head. Also look at the tail. Look at our tail, you can see all those missing values are coming up. Okay, now the next thing to do is to look for is null. Is null is talking about the values that are null. So when you run it, Whenever there is a missing value, we see is null. So to show you false, if there's no is null, that means the values are there. The one that don't have value will tell you it is true that is null is applicable. You can see some true value, which is those ones are missing value, and numbers of our row are also indicated to the 3000 rows. So we'll code down again. You can also use is any, and it will still give you the same thing as is null. So in case you see some literature that will tell you is any, is same thing. Now other one is not null, is the opposite or the reversal of is null. So the ones that have missing value will tell you true, there is missing value. The one that doesn't have missing value say false, there is not a missing value. So you can also look at is any. So this for is not null, true is not null, false is null, just the opposite of what we just said. So we want to see the sum of is null. See the location, date, new case, date are all complete. Population has some missing value. Then the older percentage, GDP per capita, and hospital beds have more missing values. Okay. So if the question is show me the row where all the age 65 older percent score is given, we use this formula DF, then you bring in what you want to do, dot not null and run. So you see it, these ones are the ones that are given. So assuming you want to work, you can use that to do your working, and you get your 20,000 for 3,000 is given. Now what this is telling us, and when you want to see where the age percent is not given, where it is null or is NA, then you run the next line of code. So you see it here, then you can see the number 2439. Okay. So show me the row where all the age 65 older percentage score is not given, but GDP capita is given. So it's now we have two conditions now. We want to see where the our age parents are given, where their value are not given. I mean, it's null, they have no value. At the same time, that particular one that are not given, GDP is given. So maybe this one, maybe you want to raise some important question. How come this was not and this was? And it will help you to do that analysis. So normally our interest is done to see from just like intersection again, 649 rows. Satisfy that condition. So how do we drop our rows now? So normally we drop it with what? Drop any. So it will remove the row which contain even one missing value. So drop any is used to do what? To drop those values. But you should also be careful that drop any does not always drop values. When there is other issues that are wrong with your data, it may be possible for you to do a lot of analysis and use some other criteria to do that. But have it in mind as you continue to work within those criteria. This one you can also drop NA with threshold equal to 1. So it means drop only the row if it contains one missing value only. So the one that have more than one missing value will be left. So now fill NA value. You can also learn how to fill your NA value apart from using those mean and the rest. So if you have an NA value, for instance, you can use maybe this write-up to fill up any place that is NaN. You can replace it with it, a kind of a filling pattern, just for practice sake. See, you was able to close all those places that show NA. Of course, this is just kind of a practice. In real working, we don't do this. We go straight to use what we want because it's real business. We'll get our work. So we want to fill in, for instance, with our mean DF hospital beds per 1,000. We want to fill that NA with what? The mean of hospital bed. That's what it's saying. So when we run it, see, this is the mean of hospital bed. This is the mean we have used to fill it. We can also round it because of the plenty of decimal. We can round it up just by 1 decimal place to reduce those values. So when you run it, it has now filled those places. Let me see. It's called DF. Let me see DF head to see if it has filled the hospital bed. Let me add a value and see DF dot head. Let's see what we have here. I'm interested in the hospital bed. Okay. Let me also go to tail. Remember, most of those values were on the tail position. And let's say DF dot tail and see what it will look like. See, it did not work. It did not work. So when we come to the work, we do it properly. Do it. These ones are for smaller little work, but for technical work, we have to step it up. So group by operation. Group by is another important aspect of Pandas that can be used to group our work for other understanding. So if we come again and return our, when you are grouping based on criteria, based on behavior, based on attribute. So we bring out our data has CSV again. So our data set is set. So we want to count the area value count. So DF area locality value count. We'll look at it. We'll want to look at size. You can see that this is area value count. Let's observe. This can accept both strings and the integer. So we'll run the other one for size now. Size is just giving us the value of that object from the beginning to the end. Anytime you see this dot, something is in between. So if we have this, we can now group our work, our data frame by mean. We are grouping it by mean. So how do we do that? Run it. So you see that we are using the size, the mean of the size to calculate all this. So we'll get the mean based on the size. So we are grouping everything based on size. So we can do that for more than one, or even did for two columns, size and rent. And we're looking at the mean. And how for us to do this grouping. So you see size and rent. For rent. Can even describe function. Can use describe function to run our rent, for instance, transpose it, and at the same time round it. That's what we have just asked the system to do for us. So we are describing. Not only are we describing, we are also so want to the data frame group by rent, renting grouping by rent, and the same time describing and transposing and rounding our value to 2. So this is what we have just done here. So based on rent, you can see the BHK size and bedroom. You can see the mean, standard deviation, everything is captured in just this single line of code. Now we can also go ahead to do combining our data frame through concatenation. So often the data we need exists in two separate sources, which is normally true in real life. So Pandas makes it easy to combine these together through concatenation. So how do we do it? We want to have a hypothetical data we want to work with. We bring out this explanation. So we have data 1. It has something like a dictionary. You have A, and A has A0, A1, A0, A1 to A3, and B has B0 to B3. You have data 2, which is C. It has C0 to C3, and D has D0 to D3. So we run it, bringing them to memory. Now, data frame 1, PD, want to see the data frame of data frame 1, and also the data frame 2. So when we put up the data frame, it will come up well. You can see the index is here and the column are here, and you can see the values inside. And the same thing is applicable to data frame 2. Data frame 2. So now we want to concat, want to merge them. So we are using pd.concat df1 df2, and the axis is axis 1. We are combining on column. So we run it. You see it has brought A, B, C, and D together because we are running on column. Now if we want to concat on row, you see that the axis is on 0, but let's look at how it will look like. So if you are running on row 0, 1, 2, 3, 0, 1, 2, 3, because you are combining on the axis on the row, but you see that a lot of non-value will exist because those ones does not exist there. So it's not a good way to do it, but we just want to show you what is possible, but it doesn't make sense. So we can know that it's not a better approach to join table if I've done that. So to join table along row, name both the column will be matching. So if you want to do it along the row, the column name will be matching. So df1 dot colon equals to df2 dot colon equals to df1 dot colon. So we have made an important definition here for column before we continue our work, because we want to see a better rule combination. So we must match it first before we combine. So when we concat it now, we see a better value, A and B, and it will now align. And also merge. This is analogous to join in SQL. When we're merging, just like you're doing joining, inner join, outer join, left, right join, among others. So the merge method take key argument level of how. There are three ways of merging. How? You see that you are merging inner when you are only looking at the what is common to the two of the merging criteria, or outer when you are looking at everything. Then left and right when you are looking at what is in all in left that you can also find in right, or when you are looking for what is all in right that you can also join to left. So we have some data we just provided here. Registrations, say PD data frame, range, name, login, PD data frame, login ID. You see that login ID and the reg ID is the same but different name. So when we work on the registration, we see reg ID 1 2 3 4, names are there, login ID 1 2 3 4. These are the login for the same people. Either the names are there, but the login ID is giving us a different thing. So we want to perform inner join first. So we say PD merge registrations and login. How? Inner on name. So you now run. So reg and name and login ID will now come up. Reg ID, login ID. Okay. So we can also merge on left and on name. So when you are logging on something, that is the common feature for the two. So left joint is what is available to registration, which is the first, that can also, all that is in registration and what is in registration that can be seen in login is what we are joining here on name. So registration, everything registration 1 to 4 is there. The name in registration is also there. Now, what is in registration that can be found in ID is only 2 for Andrew and for Bob. That is why this is showing now. That is left join. So for right join, want to look at what is available, all that is available in login first, then whatever is in common with login and registration will now come and it will be joined on name. So the name for logins are all here and login ID are all correct. Then you now see what is common to login and registration. It's only 1.0 and 2.0. That is why the rest are none, because it is joined on name, just like an SQL joining. So when you know how to do join in SQL, you will not have problem. So the outer join is taking everything is being there, that is outer join. So you now see the reg ID, the name, and it's joined on name because name is value common to all. So every name will appear here. For the reg ID, the name, the one that is not available will come on null value, and the rest everything is captured using outer. So anytime you are doing outer join, be sure that you see a lot of null values. So text method on string data. Often text data needs to be cleaned or manipulated for processing. While we can always use a custom apply function, the text pandas come with built-in string method. So when we look at this value down, let me go up a bit. I want to split. So you see our email, we have, it's a string, so we have the apostle. So you say mail@gmail.com. So you want to split this. So you say email.split. So the split is what we use. Then it will ask you, what do you want to split on? So we want to split on art. If there's a space, you can, this is a point, you can also split on period. So you can even split by position. So but you are splitting on art. So if that is correct, you run it. You see now, it has splitted Mali, for instance, at Gmail. So you can also use your name. For instance, you can use Victor Tunji at gmail.com, for instance. And when I run it, see it will split at Victor, then gmail.com. So this is the splitting, so you now see it. You can also split again. Let me add a column here. You can also split, copying this. Okay. You can also split, for instance, using period. Here we use this. You can use period. You can see there's a period in our work at gmail.com, and we'll say split to run. See, it will Victor Tunji at gmail.com. So that is splitting. It is can also change this. You can say Jude Gates, for instance. So you want to use digit. Want to use this digit to split to, you run it, and it tells you it's false because this name is not digit. This is a string. And now the next one we now run, say 7 is digit, and it tell you 7 is digit, which is true. So like in this name now, you can use Jude, use Victor, use Tunji, for instance. So this is names, and it's a series, because it is just like a pandas data frame, but it's on the single dimension. So you run it. So you want the names, it will come out the way it is written. Now you want it to be in upper string. Now I want to use the upper. Remember in Excel we also have this logical activity we work. So when you click on upper, it will give you everything in capital letter. Also you want it to come in a string capitalized. That means the way it's supposed to be. If you are writing, the first name will be capital letter, other ones will be single small letter to come out that way. Or you want it to come as lower value, lower letters, you use the lower, and everything will come in lower value. So this, let's do some correction. Like this, we have Uju. We start with, we have Victor. We have Tunji. When you look at this, you see that the arrangement of the names, the spelling is not well done. They are called messy name. So if we have something like this in our work, I want to bring it out. Let's look at it. See that the messy names are there, not making sense. So we can use this stripping to actually correct it. So when we put messy name string or strip and capitalize, that means we want the name to be arranged accordingly. See, they have not been arranged accordingly. So we have been able to look at the work. We have been able to do justice to pandas as we enter into machine learning. These all that we have treated today are of very important, both in entering, both in sorting our data and in the manipulation. We are going to see them in your machine learning work. So please study it like a Bible. Look at it very well. Take them line by line, and by the time we start the machine learning, it will be a walkover for us. Thank you very much. Do have a lovely day, and the knowledge be with you. Have a lovely day. Bye bye.
In today's world, data is the new gold. Data scientists unlock insights from raw information. They use statistical methods to analyze trends. Data analysts convert data into visual stories. By creating dashboards, they help organizations make informed decisions. Machine learning models can predict future outcomes. They identify patterns that aren't visible to the naked eye. Data cleaning ensures accuracy and analysis. Collaboration across departments enhances data insights. They utilize programming languages like Python and R for analysis. Cloud computing resources expand their capabilities. With big data, they tackle complex challenges across industries. Ethics in data science ensures responsible use of information. The future of data science looks bright with endless possibilities.